Hey everyone, time for us to begin exploring a little bit more about granularity with regard to how we conduct or generate summary routes. Now in our topology, I did a default summary route on R22 such that when I look at the system on R1, show IP route, results in the existence of a default route that I learned via EIGRP, and I'm going to be able to do load sharing to reach those destinations. Now, what I did not do is I did not configure a default route on the R1 configuration. You would do it under the exact same place that you would do the regular configuration, so it's going to be under the AF-interface. And what I'm going to do is rather than do a summary or a default summary, what I'm going to do is I'm going to summarize my 11.11.0.0/24 prefixes like we did before. And then what I want to do is I want to play around with a new construct. All right, so looking at this, on R1, all I want to do is go into my configuration. I'm going to say config T, router, EIGRP, named, address family, IPv4, autonomous system, 10, AF, interface for E00, and what I'm going to do is I'm going to do a summary address for 11.11.0/20. I want to do all 8 of those. So again, I'll come up here and do E01 and advertise the exact same configuration. Now, with this being done, let's go over to R2 and see what we can see in our show IP route, our routing table. So we're looking for 11. And notice here we see I've got this one. So I've got 10.10.0.0/20, and I also have that more specific /24 for 16, because remember that /16 fell out of the bit boundary. I would have had to have done a different summarization to get that one. Now, looking at this, it's important for us to realize a few things. It's important for us to realize in the confines of R22, I'm learning just the summary address for those interfaces that are part of that range. So what I'm going to do, just to make sure that we don't get any type of confusion, I'm going to go over here to R1 and say interface LO116, and I'm going to shut that down. Now, that should remove that from R22's routing table. Let's make sure that that happened. Notice it's gone now. So the only 11 prefixes I have are the first 16, 0 through 15. Remember, we're counting concatenately. Now, what I want to illustrate here is the fact that I have the capability of modifying the behavior of my process. So let's look at this first of all from the point of view of R22. R22 is advertising that default route. So it's advertising that 0.0.0.0/0 and 0.0.0/0 prefix, that quad 0 prefix. Now, what would happen if I said that I wanted to advertise that, but I want traffic destined to, let's pick an address. Let's say destined to 22.22.7.0/24. Traffic that's destined to that particular prefix, I want that traffic to only traverse this way. Now, the way that I can manipulate that is well, remember, we talked about the fact that longest match rules. Now, right now, this is not an issue. I mean, we're actually sending a quad 0 prefix. So there's nothing less specific than that. So if I could select this network of 22.22.7.0/24 and allow it to be advertised out using its native mask, or any mask that's longer than that's longer than the default route, then I would be able to actually allow the user or the administrator to select which path to take to reach that destination. Right now, if we look at it, I go to R1 and I trace route. So if I trace route to 22.22.7.22, it's going to go through, actually hold on here, what's going on? I'm not load sharing. Show IPEIGRP neighbors. Do I have an interface off still? You all. Show IP interface brief. E assigned. Everything is up here. Let's go to Cat 1 and Cat 2. Show IPEIGRP neighbors. And go to Cat 2. Do show IPEIGRP neighbors. Alright, so it's got to be something on R22. Show run interface E00. Oh, S0, S20, and S21. Ah, look at that mess. Config T interface serial 2, 1, no. Get rid of this. Let's see what's happening on R1 now. Show IP route 22.22.70.255.255.255.0. It's not in my routing table. Oh. It's because I'm advertising this, the default route. So let's see, trace route to 22.22.7.22. Now I'm load sharing. Okay. So pardon, there was an artifact configuration that was left. So with this being said, what I was trying to do is I wanted to say, well, I want to reach this network of 22.22.7.2.7.0/24. I want to reach it via R3, not R2. So I don't want to load share to reach this specific interface or this specific network. Well, how can I do that? Well, in the confines of EIGRP, there's a tool. That tool is referred to as a leak map. Now, a leak map allows me to identify prefixes that I want to be advertised in concert with my summary. So the idea here is that rather than take all of those prefixes and change them to a shorter prefix length for summarization, I'm going to change them, and then I'm going to have the same capability or the capacity to say, okay, but I want to leak this one out. That's where the term leak map comes from. And it's only supported in the confines of EIGRP. So when we go in and we do this manipulation, what we want to do is realize how we can make this happen. Well, first of all, I'm going to need to do my configuration on R22. And I'm going to want to leak the more specific out of my preferred path. So it's going to be config T interface serial to 1. That's the interface pointing to R3. Do show CDP neighbors, and we can see R3 through serial to 1. Now, with that being demonstrated and accomplished, what I want you to also to note here is that I have the capacity to do this, and it's going to be using this idea of a leak map. So do show run interface serial 2/1, and what I see here is I have my summary. So I'm just going to repeat my summary. But what I'm going to do is at the end of this, I'm going to be able to specify a leak map. Now a leak map calls up a route map. So I'm going to say leak map, and I'm going to say leak LO 107. Now I don't have anything configured right now. So when I go back over here to R1 and I take a look at this again and say hit this, there's no change. It's still load sharing because I haven't created the route map that I'm going to use to detect this. So what I'm going to do now is I'm going to say route-map, and I'm going to give it a name, leak _ LO 107 permit 10. Now what I can do under here is I have a number of options. The one that I'm going to harp on right now is going to be the match command. I can match on specific values. I can say match, and I can match on different components. So for instance, let's say I can match on an IP address, and I can call a prefix list, I can call a named access list, or I can call a numbered access list. And I'm going to say I want to match on the IP address of 0, We'll say IP address 1. So that's going to be access list 1. Then what I'm going to do is I'm just going to plug in a deny here. Deny 100. And now what I need to do is configure this access list. So I'm going to say access list 1 permit. And what do I want to permit? Well, I want to permit the IP address 222270 and hit enter. Now, here's the interesting scenario. Let me end this, and then I'm going to clear IP EIGRP neighbors, hit enter, and this should refresh my connection. Notice it says down, down. My adjacencies are now back up, so everything seems to be good to go here. Now let's look at this access list. Show access list 1. Now notice it's been hit 4 times. I have 4 matches on this access list. Now that's interesting. So let's take a look and see what's going on here. Well, what I did is I show run or show route-map. What's happening here is I'm saying the leak map LO107 says anything that matches this address is going to be something that I'm going to permit. Everything else I'm going to deny. So when we looked at this, we had 4 matches for that access list. Let's take a look at that access list again. Show access-list. Notice it's 222270. Now what I want to do is I want to illustrate or take a look and see what's going on here, but I need to do that from R1's point of view. What happens when I repeat my trace route? Notice now it's going to cat2 up to R3 and back to R11. So if I track this through, it's following the path that I said that I wanted it to follow. It's going to cat2 to R3 all the way to R22. Now the reason that it's doing that is what we did to the routing table. Show IP route. And when we scroll up here, what we're going to see here is notice that my default routes are still here. But before what was happening is the only route that I had was my default route for anything that was here in 22.0.0.0/24. Now notice I'm learning a EIGRP generated prefix to this network from cat2, and that's going to be the reason that I'm doing this, or I'm sending the information to cat2, because longest match prevails. /24 is much longer than /0, therefore that's the way that I'm going to send traffic to reach my desired destination. Now what happens if I want to do this for 2 different prefixes? Let's pick another one and see if we can't modify it. Well, what I'll do is I'll come up here and I'll say trace route to 2222, and we'll say 622, and I'm going to find that I'm going to load share. But what I want to do is I want to use R2 now to reach this destination. Well, let's cut over to R22, config T, and what are we going to do here? We're going to need an access list. So let's say access list 2, permit. What am I going to permit? Well, I'm going to permit the network 2222.6.0. Now let's make a route map. It's route-map. I'm going to call it leak LO6 for leak loopback 6. Permit 10 match IP address 2. Go ahead and just plug in a deny here just for good measure. Deny 100. That's just a sequence number. Then what I'm going to do is router, or actually I need to go to the interface. I'm going to say interface S20. Do show run. Interface S20. And what I want to do is I want to modify this summary with another leak map. So let's go through here and say paste leak map leak underscore LO6. Notice I resynced. Let's see what's happening to my access list. Show access-list 1, show access-list 2. So something's hitting my access list. So now let's repeat our test on R2 with regard to doing our trace. If we got our sums correctly, it should traverse R2 instead of R3, so there should be no load sharing, and we can see very clearly that that's exactly the process or the outcome of our test. Now, I could leak multiple interfaces. So I could leak evens and odd interfaces. Let's take a look at that. But you know what? Let's look at that. We'll look at that in another video. Sorry about that. We'll look at that in another video. I'll attach it to the backside of this one, and I'll see you guys there. Because it's really interesting, or it's going to be really important that we learn how to manipulate these processes. So let's see what ends up happening when we do this. I want to be able to leak specific routes.